A2 Maths, inverse and reciprocal trig functions. Right, what I'd like you to do is just have a go at sketching out what you remember the sine graph to look like. So you should be able to do that without diving through your notebooks. You should know what the sine graph looks like. Okay, so have a quick go. Right, so you should remember. If you don't remember, don't forget you do have your calculators. Your calculators can remind you about some of the key points, like what sine 0, sine 90, things like that. But you should be able to sketch the graph of y equals sine x. It was one of the ones you learnt last year, hopefully off by heart. I've done it in radians here. It's important to be able to sketch it in both radians and potentially in degrees. Like I mentioned, 90 degrees. You should be able to sketch it in both. Okay. Right, why's that not got an inverse? So if we just come off the previous lesson, you know it hasn't got an inverse because the sine graph on it at the moment is what we call a not one-to-one graph. It is not a one-to-one graph because if I want to get, for example, 0.5, I could put that value in, gets me 0.5. I could put that value in, gets me 0.5. I could put that value in, gets me 0.5. There's many different answers that can get me 0.5. So it's definitely not a one-to-one graph. Now to make it a one-to-one graph, I'm going to have to restrict its domain. I'm only going to be able to look at it over a very small amount of values. So hopefully you can have a look at that and you can think, yeah, I can see which values would work between. Okay, so have a think about it. Which values would work if I wanted to restrict the domain? But I also want to maximize the possible range. It's no good just saying I'm going to restrict it from 0 to pi over 8. That would be right. I wouldn't say it's wrong. It is a one-to-one function, but you want to make sure you extend the range as much as possible. So if I went to pi over 2, that would be better because I've got more values. But is 0 to pi over 2 the best? No. I could go from minus pi over 2 to pi over 2. Those values there would get me the maximum. Anything bigger than that, I'm starting to hit the same values coming out. That's no good. So I can only go between minus pi over 2 and pi over 2. Other solutions might be those ones, or over here, between those two. But the obvious ones, the easiest ones, are the ones that focus around 0. So a restricted domain between minus pi over 2 and pi over 2 would look like this. Any further stops it from being one-to-one. So what I'd like you to do now is see if you can sketch out what the inverse graph would look like. So that's the function of y equals sine x. Just have a go at thinking what would the inverse function. Now a bit of a hint to you, I've done it on squared paper there. Notice that my axes are equally square. So that's a big hint to how it should look. Okay. So pause, give you a chance to have a think about it. Yeah, so now that I've done it on squared paper, notice that my dotted line would be up here. And as you picked up hopefully from the previous lesson, if I'm looking for the inverse, that means it's a reflection in the line y equals x. Now the line y equals x would go up like that. So if I reflected this curve in the line y equals x, some of the points would go over to there. Some of them will be very close, so they wouldn't change at all. So I'm going to get a graph that sort of looks a bit like that and a bit like that. So it looks almost the same, except it's going to sort of rotate this way. So let me draw the line y equals x on. There we go. Reflect it down. So these are going to go to there and so on. And it's going to end up looking like that. You can see where they're reflected over. I'll make sure you get that in your notebooks. You've got to be able to sketch the graph of y equals sine to the minus 1 of x, the inverse function. As you can see that with a minus 1 function coming in, the inverse function to y equals sine x. You've got to learn it. You've got to learn how to form it. You must make sure you know it for that exam. And on certain lessons, I will just ask you to sketch that out for me. Okay, so pause it if you haven't got it down yet. one side the same, but this time with cos. All right, so have a go at quickly sketching cos. Pause, have a go at sketching it yourself. Hopefully you got this graph, y equals cos x. 0 got you 1, 90 degrees would have got you 0, 180 degrees, which is pi, would have got you -1, and so on. That should have been enough to be able to plot it. Okay, same idea as before. It doesn't have an inverse because we need to restrict its domain. Almost the same as before. What would its restricted domain be? Well, very similar to last time, we need to go from the peak to the trough. So I wouldn't blame you for either going that direction, from minus pi up to 1, or from 1 to pi. Now I'm picking 1 to pi just because it's positive. No reason not to pick the others. Notice that you can't go between previous domain because then you would still have a many to one function. That value gets me exactly the same as that value. So the restricted domain is anything between 0 and 180 degrees. So 0 to pi. Right, now I know it's from 0 to pi, and I can sketch that down. Notice why it's important to make sure. I said to you a minute ago, this is almost squared paper, as it was before. But these values, as you know, that's about 3 just there. So they're very, very similar. So this one here, what's the graph going to look like? Try doing it yourself. There's your line of y equals x, sort of going up like that. Mine's almost square on. So have a go yourselves. I'll pause, see what you got. This one's a bit tougher, I'd say. So can you find cos of -1? Okay, let's see how you got on. So this is on square paper, and this is why it's important that you have to do it in radians, because if this was 180 just here, you can imagine that to go up to 180 would take you well out the top of the board, up there, probably through your window, your roofs of your houses. So we've got to make sure that we're dealing with radians, because then we are dealing with a nice easy graph to work with. We are not dealing with degrees. So there's my line y equals x. Let me just put that on for you. So if I'm reflecting, I know that value would end up here. I know that value there will end up over here. This one on this side would have gone right over to onto this side. So what does that mean? Well, it means that you're going to get a graph something similar to that. What you can do is you can fold a piece of paper to see it on there, or reflect in the window. Whichever method you choose, most of you should notice that it is the sine curve, or the cos curve, excuse me, but just on its side. If I want to carry on going, it goes like that, and then up like that. Okay, so it's cos graph on its side. Again, pause until you've got it all down nice and neat in your books, so that you don't miss it. And then we're going to have a look at the tan graph. So there's the tan graph. Didn't ask you to sketch this, but you should know it. Same idea. I want to find the inverse. Must have a restricted domain. What would its restricted domain be in this case? Well, exactly the same as the sine curve. It goes between its asymptote just there and its asymptote just there. So the restricted domain is only those two bits just there. So it's just the central part of it. And just to double check, whatever value you put in, now definitely got just one answer coming out. Obviously minus pi over 2 and pi over 2 don't work. They're not in the domain anyway. So it's anything between those two values would definitely get me an answer. A unique one-to-one function now. So what I can do now is I can have a go at thinking about the line y equals x and sketching it. You want to pause and have a go yourselves. I draw it myself. Think about what's going to happen. Okay, so that you've hopefully had a go yourselves. If not, if you got stuck, I don't blame you. It's a bit more of an interesting one again. There's my line y equals x. So the inverse of this should be a reflection of that line. So what's going to happen? Well, that point's going to go to there. This point's going to reflect somewhere down here. That point's going to reflect somewhere over here. So what you're going to end up with is a graph that sort of does that and sort of does this. Notice that the asymptote of minus pi over 2 that was in the domain becomes the asymptote in the range. The asymptote of pi over 2 in the domain becomes the asymptote in the range. And it's also worth pointing out, as you can see, that originally the restricted domain was between these values just here, but I could get any value out. Now that domain has become its range of what values can come out of this inverse, and as before it had a range of all values. That's become the domain of the inverse. So the range and domain have swapped places. Right, so if you haven't done it already, there's your inverse graph, your tan to the -1 graph, and yes, you have to learn that. You have to learn all three of those inverse graphs. Okay, so pause if you haven't done it yet. Right, and what's important, because I don't blame you for thinking it, that the reciprocal of sine x is 1 over sine x. That's what we mean by reciprocal. Reciprocal is 1 over. And what's important is to note that this is different to sine to the -1x. Although you might think, well, isn't mine to the power -1 1 over? In most cases, yes, it is true that something to the power -1 would be 1 over. But unfortunately, it's not true for the trig functions. So sine to the -1 and tan to the -1 and cos to the -1 are not the same as 1 over. Okay, they are very different. So why are they different? Let's just have a quick look at each of those. So sine 1 over sine graph can be written, because they are different graphs and they are different to these types of graphs, they actually have their own name. So 1 over sine x has the name cosec. The cosec graph is the reciprocal graph of that. Okay. 1 over cos has the name sec. Okay, its full name is secant, but they just shorten it to sec. Okay, the same sort of idea. This is the cosecant. Is the same reason this was the cosine, and this is just a sine. All right, so the co is in front of both of those. Tan, 1 over tan function, so the reciprocal of 1 over tan, is called cot. Now, yes, you have to learn these names. Yes, you have to learn which ones go to which. My hint is this. Learn the name cosec, and the third letter tells you which one it goes with. So cosec, learn it. Third letter S goes with 1 over sine. Sec, learn it. You've got to learn the name sec. Third letter tells you it's 1 over cos. Cot, you've got to learn the name. Third letter T, 1 over tangent. So the third letter rule reminds you which one it goes with. Okay, but yes, you have to learn those names. But the truth is, by the time you get to the end of the course, you will have used them so much they'll become second nature. Very much like sine, cos, and tan. Okay, but let's have a look. These are what we call the reciprocal. Very different to the inverse. They are nothing to do with the inverse functions at all, but we do need to learn what the graphs of these look like. And let's see why the functions are very different to the inverse graphs. So we want to look at the graph of sine again. There we go. Beautiful. There's our graph of sine that we dealt with before. And we know the inverse function had to deal with just a part of the restricted domain. That's not true for reciprocal graphs, not true for the 1 over graphs. Now, if I want to plot the cosec graph, noticing that these two are similar, because that's just 1 over, and 1 over sine gets me cosec, 1 over cosec gets me sine. They are very closely related. I want to sketch this graph. Let me just try some of the key points. So for example, I want to look at 1 over sine x. So if, for example, I want to look at these points when sine x equals 0, just there, 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 and there, now 1 over sine x is going to fail because they can't divide by 0. So if sine x equals 0, then the reciprocal graph is not defined at all at those points. Now, if it's not defined, if it doesn't work, that's what creates an asymptote. So the graph of cosec, I know for a fact that at these key points where the sine graph equals 0, it must have an asymptote. And that's a good starting position. Stick those lines in everywhere you get a 0. It'll be true for cos as well. So I'm going to put those down for the asymptotes. Right, what else do I know then? Well, let's look at another important bit. The sine graph equals 1. I know that. There, and so on all the way across. Now, 1 over sine x, which is cosec, will also equal 1. Why? Because you've got 1 divided by 1. 1 divided by 1 is definitely 1. So what I know is it's definitely going to be there and there. Cosec graph definitely touches there, definitely touches there. So let's mark those down. And for a similar reason, we can do the same on the bottom. So when it's minus 1, okay, 1 over minus 1 is still minus 1. So I can definitely know it's going to cross that. So this is quite interesting. It's got an asymptote. It's never going to cross that line. It's going to touch there. Okay, and then it's got another asymptote, and then it's going to touch there, and so on. That's what I know so far. Right, so let's do some more investigating. When the sin x graph is very small, so we're talking about just there, just when it's got past 0, so maybe it's like 0.01 when it's really small. Not as big as up here when it gets to 1, but just here where it's really small. What we notice is that 1 over something really small is also really big. So when you do something like 0.1, 1 divided by 0.1 is actually going to get you 10. 0.01, 1 divided by 0.01 is going to be 100, and so on. So a very small value there means that that gets very big. What does that mean on our graph then? Well, when this is really small, the 1 over sine graph, the cosec graph, is going to be really big. It's going to be up here. Small sine curve graph, small value on the sine graph, big value on the 1 over sine. Now this is also going to be true for the negatives. So something very small but negative would get you something very big negative. So what I know is it's going to be up here somewhere. That means I can now plot it. And notice it doesn't matter how hard you try, this 1 over cosec, the cosec graph, the 1 over sine graph, you're never going to get a value between 1 and minus 1. Doesn't matter how hard you try, it's never going to happen. You're never going to get a value between those two. Why? Well, let's have a think about this. How are we going to get a value of, let's say, a half just here? Now, the only way you're going to get a half for cosec, remembering that cosec is 1 over sine x, if I want a value of a half, that means the 1 over 2, that's what a half is, the 2 has got to be the sine x bit. But sine x can't equal 2 because sine x is restricted between minus 1 and 1. So you're never going to get a value in here because you're never going to get a value of sine x bigger than 1 or smaller than minus 1. That graph, I apologise, you need to make sure you sketch it down in your notebooks. Let's have a look at cos, similar idea. So the graph of sec, 1 over cos. These two very closely related as the other ones were. Same ideas then. 0, 0, 0, 0 is definitely going to create asymptotes at 1 over 0. So I'm going to plot those in. The 1 and 1 are going to create 1 over 1, which is still 1, and minus 1. 1 over minus 1 is still minus 1. So I definitely know those. I also know that small values create big values for 1 over. So I can definitely know it's going to be crossing up here. So what do I get? This sort of shape. And this time I'll give you a bit of warning. You need to make sure that you sketch that shape down. And you've got to learn that shape. You can ignore the blue one. That's important. The examiner will expect you to make sure that you've got it lined up with 1 and expect you to have your peaks just here lined up with minus 1. Doesn't expect you to put the blue curve in, but you do need to know this graph, which is the sec graph. Notice it's got nothing to do with inverses because it's not one-to-one functions. Okay, nothing to do with inverse functions at all. Right, I'll pause, give you a chance to make sure you got it down correctly in your notebook. Right, the tan graph then. This one's a bit more interesting, a bit different to before, so let's think about what's going on. The inverse to this will be the cot graph. So we want to think how to plot the cot graph. So nice and neat in our notebooks. We can't do it yet because we haven't plotted it. So what do we think? Well, we can do the same idea as before. Notice there is some zeros. 0, 0, 0, 0. So zeros on the tan graph will create asymptotes on the 1/10 graph. So I could definitely put those on. All right. Now what's interesting about this is the tan graph had asymptotes itself. So asymptotes itself means that we're going to have the opposite effect with this one. But before I do that, let's do this first. So when tanx is very small, so there we go, just tiny little values, we know that 1/tan is very big. So when this is really small, the tanx graph is going to be really big. So it's going to be big there, it's going to be big there, it's going to be big here, and it's just small there, so it's big there. So those values. I also know the opposite is true as well. Okay, that when it's really small, I'm going to get really big negative numbers. So small negative, big negative on the 1/, graph. Right, so I'll go from there to there. I can see that it's going to travel from there to there. Now, what about in the middle though? Well, the one thing I do know is here there are some asymptotes. I haven't drawn them on. I didn't want to get confused with loads of asymptote lines, but there's definitely an asymptote for the tan graph. Now, just like 0 creates a 1/0 asymptote, the reason why this asymptote is here is because you were trying to do 1/0. What does that mean? Well, it means that cosx is going to equal 0. 0 on tan means that cot goes to an asymptote. Asymptote on tan means that cosx must equal 0 because they're opposite, they're reciprocals of each other. So I can put in a 0 there. So what happens is it comes down to that. Don't do it as a straight line. It's not a straight line. It is going to be almost the same as the tan function. It's going to look like that. So there we go. You can ignore the blue lines, but in your notebooks, you should be sketching this tan curve just like this. In fact, if you, sorry, not tan, cot curve, just like this. What's important is to notice they are very similar, aren't they? They're almost the same, except it's sort of reflected and shipped over a bit. And it's important to remember that they are similar, so you don't make a mistake on the shape. Okay, so the cot graph looks like that. So as long as you can remember it off by heart, my advice is to make sure that you've got all 9 of your graphs drawn down somewhere really obvious when it comes to your revision, so that when the examiner, or if the examiner just says sketch the cot graph, you know how to do it. Okay, you either know how to form it like I've done, or you've just learnt it off by heart. So the 9 graphs, sine, cos and tan, hopefully they're set in your heads. The inverse graphs, sine to the -1, cos to the -1, tan to the -1. But also the reciprocal graphs, the 1/sine, which is called cosec, the 1/cos, which is called sec, and the 1/tan, which is called cot. You need to learn all 9 of those graphs off by heart. It's worth being aware that the inverse functions, sine to the -1, cos to the -1, tan to the -1, can sometimes be written with what's called an arc function on the front of them. And you don't have to use this. If you want to use sine to the -1, cos to the -1, tan to the -1, that's perfectly reasonable. But you need to be aware of it because it could potentially come up in your exam papers or any other questions. So for example, if you had sine to the -1, another way of writing that would be arc sine. So arc sine would mean sine to the -1. You need to recognize that fact. Same with cos to the -1, arc cos, and tan to the -1 is arc tan. So as I said, they're just alternatives. You don't have to write them with an arc function yourself. And if you see them in a textbook question or an exam question, you can replace them straight away for sine to the -1, cos to the -1, and tan to the -1. They are the inverse functions.